I, perhaps ask a question about the quiz?
Yeah, let's do it. Go ahead.
So I think it was the second or third question. It goes back to the density altitude chart. I struggled a little bit on just the left side of the chart, mostly because I was doing it on a screen. I was holding up a piece of paper. That may not have been the best way to do that. But my question is so once I've done the calculation, so I looked at the altimeter, got the density altitude adjustment, adjusted my altitude, and then went back to the graph where the temperature setting was and went up. And I wasn't quite sure how to work with the slanted lines with relation to the y-axis. If we could just do like a 2-minute refresher on that, I think I'd be back to good.
Yeah, let me share my screen real quick here. So on the density altitude chart, like you mentioned, you made it through the aspects of finding pressure altitude, either by adjusting your altimeter or by doing the math, the conversion on the right there.
Yep.
And then how to actually get density altitude using the chart. So once you have, obviously you're given your temperature, and then once you have your pressure altitude, those are the only two pieces of information you need. Easiest way to do it is enter the bottom of the chart. Let's just say, for the ease of the question here, we're going to do 70 degrees Fahrenheit. So I'm going to enter the chart at the bottom here at 70. And let's say our pressure altitude is 3,000 feet. I'm going to draw a line from 70 all the way up to the 3,000 slanted line. And then I'm going to cut straight over. Oh, geez, that's really not flat. I'm going to cut straight over to the y-axis, and that's going to be my density altitude.
Okay, so the quiz ended up being, I think, 58, 77, and 81 degrees Fahrenheit. And the reason I got a little confused is it looked like they took the 58, 77 right up to the 6,000 line. I mean, it was just shy, and so it just seemed like a little bit of a stretch. And so I wasn't sure if I was really looking at that right, if they were just a little bit more forgiving with the accuracy of where 5876 was. So I think for me, that where it got a little confusing is you don't intersect anything at 5876 pressure altitude. So you'd be right in between the 5,000 line and the 6,000 line on the slant, right?
Exactly right.
So so the answer ended up being 8,500 feet. And if you take, I don't know if this is the one from the quiz or not, but if you take, yeah, okay, it is. So if you take 8,500 and go to the right and intersect at 81 degrees Fahrenheit, you're awfully damn close to 6,000 feet versus, to me, I would have thought you would have been at least a notch or two down below that.
Right. And so I'm going to draw that on the screen just to see what it looks like, but I will caveat, and this will drive you guys nuts, I know. It's one of the reasons why I suggest getting a commercially available study guide for the test, as well as taking this course, is because you're going to find that the FAA does a lot of rounding. They also do a lot of there's also, really, this will drive you nuts, there are questions on these tests where the wrong answer is graded as a right answer. So things like that will drive you nuts. But what was the temperature? 80?
81 degrees Fahrenheit, and the pressure altitude was 5876.
So that's going to be like right there, maybe.
Yeah, and so now if you look at the answers to the quiz, it's pretty damn obvious that's the right one, right? Because the other two are in the 5,000s, which means you didn't. I think they try to hit you on one once you got past the either did you do the interpolation for the pressure altitude, because the actual one they give you was in between two settings on the chart, so 29.25 versus 1.3 or 29.2. So I had done the interpolation, I divided by 2. I adjusted that on the positive side to my airport elevation, and I got, which is funny because B 5877 is kind of funny too, because 5876 is what you actually end up getting, not 5877. So you can tell that those A and B are blatantly wrong.
Right.
But C is also wrong because that is a rounding. You would actually
it's absolutely rounded, right? And in fact, when you look at the answers, let me pull up. I didn't study. Let let's see. I didn't study the answers necessarily, but let's see.
It actually walks you through pretty detailed, like what to do, which I thought.
Yeah,
was
but does it say at the end like the closest answer is? Because that's what that's what.
No, that's just it. That's what threw me off. Is if you look at the answer, it doesn't ever talk about the fact that it made some what's I'm looking for
rounding.
Yes, they did some rounding. So from the point of intersection, move to the left and read the density altitude 8500.
Yeah.
It doesn't though. It's actually more like 84-ish.
Well,
okay, cool. I was more concerned that I wasn't getting how to read the chart. And
let's do this too. So just for kicks, be talking about it, I think it's interesting. Let's see what a calculator gives us.
Okay.
So elevation, what did we say that 58?
So are we doing the adjusted?
Yeah, I believe this will be pressure altitude. So okay. Whatever pressure altitude.
76.
6. Temperature 81.
Yeah.
And oh, you know what?
925. Oh, I guess you have to do the original.
Yeah, I'll just put standard in so it won't adjust it. And then so dew point does have a very minuscule effect on density altitude, but it's not much. So this is saying 8832.
Interesting.
Yeah. Yeah, either way, you know, the FAA is going to round, and you're going to even have questions where it'll be way off. I mean, I can remember taking written tests where altitudes will be hundreds of feet off from the answer, but because I had a commercially available study guide, I knew that ahead of time. and you know, you just know which questions are off. Nice.
Okay, cool. That's all. I just want to make sure I was reading the chart right and that my assumptions were correct. So that helped validate it. So
right.
I'm really excited to see this map on your screen because I'm very hungry to learn how to read these damn things.
Oh yeah, man. This is good. This is where it starts getting fun. This is where you get in trouble because the flight planning flights, going places is the fun part of flying. Learning about aircraft performance and aircraft systems is not the fun part. However, you have to know the stuff. So it you know, that's where the challenge is. Anyway, let's get going. I've got about a 15-minute video that I want to show that I don't think we will have time for. So I'm anticipating sending that link out for everybody to watch on their own, and then we can have some like Slack discussion or whatever on it, because I believe we are going to take up the whole time, but there is a good video that goes along with this stuff. So like I said, we're going to talk flight planning. By the way, how's the audio? Good?
Good.
Okay. We're going to talk flight planning. And this is really more or less an introduction. The next couple sessions are going to be about flight planning. And quite frankly, from here till the end, I think there's only one other session that doesn't involve flight planning. So the next several sessions are going to be all about how to plan flights and execute what we call cross countries. Today's session, we're going to focus primarily on just an introduction. We're going to talk a little bit about airspace and get comfortable with how to actually plan your course. How are you going to get from A to B? There's apps out there, there's software that will do these things for you. But before you get to know those tools, you want to be able to actually do it on paper the same way that pilots have been doing for decades. And we're going to learn how to do that today. So as kind of a precursor to doing those calculations and planning a course, I want to look at some charts. There are, just off the top of my head, probably about 8 or 9 different types of FAA publications out there that we will all become familiar with starting now and going into our flight training. And I'm gonna show a few of those here right now. One of which you already pointed out, Alan, is what's called this Aviation Sectional, or the VFR Sectional. It is the most probably popular type of aviation map out there. It is for use on visual conditions, and it shows tons of information. When you start your flight training, and even after you complete your flight training, you become a VFR pilot, This will be the sectional you use to go places. All your flights are going to be planned on this. You're going to bring this sectional with you on all your trips, whether it be in paper form or on your iPad. And it truly is the most versatile chart that's published by the FAA. Regardless of what kind of flying you're doing, you'll have this chart with you. You know, I take VFR charts with me on instrument flights because they show that much. They are that versatile. I am going to show probably. I'm going to highlight a lot of the symbols here. We'll talk about a few of them, and then I'm going to give you guys some links to do some self-study because it's just there's hundreds and hundreds of things on this sectional that we wouldn't have time to walk through in a 2-hour session. But just briefly, as a high-level overview, you can see the base colors of the terrain, green. The sectional does change colors depending on what kind of elevation you're at and what kind of terrain you're flying over. So for instance, here in Texas, the flat grasslands that we live in, you're going to be green. And as you start to climb in altitude going west, you're going to start to see some higher elevations. The chart's going to change color. When you get out to the mountains, it's kind of a deep brown when you get to those mountain peaks. So, you know, right off the bat, the chart's going to give you very crucial information as far as how high you have to fly, what altitudes you have to maintain while you're flying, even down to singular points. For instance, this mountain range has a high peak of almost 12,000 feet above sea level, right here in the middle of the screen. And then, just to point out, oh, someone's at the door. Just to point out, there are other elevation indicators that, as you guys get familiar with these charts, you'll start to understand. Like for instance, this 12.3 number here is the highest, what they call the highest sector altitude. It's the highest altitude on the chart from an obstruction standpoint within this latitude and longitude boundary right here. And then each obstruction on the chart has an elevation. I would say as we get more familiar with using the sectional, the obstructions are probably the first ones you want to get familiar with, because when you do your flight training, when you take your flight test and start planning flights, the examiner is going to want to know that you have scoped out all the potential obstructions along your route of flight. Here's one right here. There's a tower. These little triangles are towers, radio towers. And then the above sea level altitude of that tower is about 5,000 feet, 4,939. A lot of the altitudes on the chart will also have their above ground level altitude in parentheses. So your altimeter will say 5,000 feet if you fly over this obstruction, but it's about 500 feet above the ground. So absolute altitude, if you guys remember that definition. So terrain, altitude planning, obstructions can all be performed with this sectional. Airspace planning is also another significant tool that this sectional allows you to perform. You see a lot of different colors and stuff on the chart. Today we're going to go over airspace as it relates to airports. There's another discussion to be had about airspace as it relates to vicinity areas that are not within the vicinity of an airport. For instance, this restricted airspace here on the screen. We're going to go into a discussion next session on that kind of airspace. But today, let's get back closer to home. Today, we're going to focus on airspace around airports. And the airports, of course, are these either blue circles or runways and magenta circles. You can see some of the airports surrounding Houston in magenta color, and then some of them are in blue color. The color difference depicts whether the airport is a air traffic controlled airport or whether it's what's called a non-towered field, uncontrolled airport. The blue is, of course, the air traffic controlled airport, like IAH and Houston Hobby. And then the magenta are non-towered airports. They operate without a control tower. It's operation of the airport is more or less up to the pilots that utilize it. So, for instance, West Houston, North Houston, and all these magenta airports around here operate without control towers.
So, Adam, quick question. Some of the magenta airports have, I'll call them spokes coming out the edges, or perhaps a star. I don't know if you want to get in that level of detail. I was just curious what those were. And I also see a rocket ship.
Yeah, yeah. So actually, really good question. The spokes, and the reason it's a good question is because this shows you like how versatile the chart is. The spokes around an airport indicate that it has, or that the FAA indicates that it has quote unquote services. And 99% out of the 99% of the time, what they mean by services is it has fuel. So as you're flying along, if you get into a fuel or an urgent fuel situation, look at your chart. If you're flying along and you've got and you're coming close to Graw Under Airport in Belleville, Texas, you might look elsewhere if you need fuel because you see it doesn't have those spokes.
I'm not seeing the spokes. Are you talking about the circles around it?
The little nubs coming off the edge.
Yeah, see like, okay.
Oh, okay, yeah.
Mm-hmm. Yep.
Nubs
What
would be a better word. I thought it was
mean?
spokes when I first said it.
Yeah, what was that, Chris?
What do the circles mean?
Around the circles around the, okay, so you see, like, for instance, let's go to let's get out of here. So like Brenham Airport in the middle of the screen. The circle denotes the airport, and the line going through the circle is the general direction of the runway.
Okay, cool.
Mm-hmm. Yep.
What's the star on the top?
The star indicates that there is a visible beacon on the airport grounds. Airports, land-based airports have what's called a beacon, which is a light that during nighttime will illuminate, so that as you're flying at night, you can easily find airports from a distance.
Okay.
Mm-hmm.
So then what does this outside circle mean? Because some of them have and some of them don't.
Yeah, so the outside circle is denotes an airspace, which in this case is Class E, Class Echo airspace. And we're going to get into that in detail here in a minute. But each airport you can see, in fact, quite a few around Houston, are surrounded by that magenta circle. What it means is everything to the outside of that circle is Class E. So in other words, outside of the radius. Inside the radius, everything is Class E down to 700 feet above the ground. And that may not mean much to you right now because we haven't gotten into detail about airspace, but just know that the magenta circle surrounding an airport tells you that Class E, which I'll define in a minute, goes down to 700 feet above the ground.
Okay, and I guess going back to Alan's first question, I mean, I would think that all airports would have fuel stations. Is that not the case?
It is. No, it is. It actually is not. Some airports don't have fuel.
My cousin's airport does not. They are a registered airport with the FAA, but it's a private runway, and they do not offer fuel. They have their own fuel for their own planes. They put in the back of a truck or a tank, but it's not a service that's offered.
Okay, interesting.
Yeah, I'm going out on a limb here with this assessment, but I would imagine if you had fuel on property, it requires all sorts of environmental licenses and stuff like that. So as a private owner, kind of like Alan said, his cousins, you can't, if you can't afford to have the environmental stuff, then you truck it in.
Oh yeah, I'm sure your insurance costs would just go skyrocket.
Probably, yeah, probably.
And it'd be harder to resell the property.
And truly, you will find Texas is actually a very good example of this. A lot of private airports. There are a ton of private airports in Texas, and a lot of them don't have fuel, probably for the reasons you guys are talking about. And kind of real good point there. You can see we have the private airports are denoted by PVT, kind of like Eberly right here, PVT.
Yep.
Yep. You can land at these airports. Of course, you would want to get in touch with the owner prior to doing that.
But you're really typically only going to be doing that if it's an emergency, right?
Emergency, or if I guess you know the people, or if you've already gotten in touch with them before, yeah. Yeah, it's not. Yeah, you don't fly into private airports unless unless you've got prior permission. Like Alan, I know Gary, and he probably would not take kindly to someone just landing at his airport.
Yeah, I think that's an accurate assessment.
Yeah. But
it's kind of cool though, because I didn't realize just how many small little airports there were.
Oh yeah, it's nuts. The availability of places to fly, Texas is great. It's really one of the better places I've flown in because I think land's available. It's a big state, but yeah, there's just a ton, a lot of choices, especially when it comes to flight schools or flying clubs.
What about more congested areas like New York or New Jersey? I'm assuming it's a lot more restricted and limited.
Well, the rules are the same, so the rules don't change necessarily, but you can tell by just looking at the airspace that there's more restrictions. Like, for instance, just from a high level, the blue circle here surrounding some of the New York airports is what's known as Class Bravo, Class B airspace. And you really, the limitations of flying through that airspace are relatively significant compared to if you're up here in upstate New York just kind of puddling around. But the rules are no different. You don't have to follow any different rules. It's just some airspaces are busier than others. It seems like every 3 or 4 years they publish new rules for how to fly up and down the Hudson River and the East River and all that. So you just have to be very mindful of what the rules are and communicate with air traffic control. So yeah, now the chart, you guys can tell the chart's pretty nuts. There's so much on here. For now, I would say for the purposes of being able to chart a course, just know that the airports are the circles, magenta and blue. The terrain is colored based on how high above sea level it is. And you've got obstructions that are denoted on the charts with their elevations here. The little triangles are radio towers and other obstructions that as you're planning your flight, of course, you want to make sure you fly over them. Yeah. There is a more detailed, I'll say more higher resolution type of sectional, and it's called a terminal area chart. Let me go back to Houston here. You guys notice as I zoom out, you've got the sectional here, and as I zoom in, if I get very close in, the chart kind of changes a bit and gets more I'll say detailed.
Yeah, that's actually a common design pattern for these types of things. You'll notice something similar with Google Maps as well. It actually replaces the image as you zoom in with a more detailed version.
There you go.
It's tiled on the screen.
It makes it a lot easier to use because before this feature was available, you had to actually choose the chart. But this chart on the screen here is what's known as the TAC, the Terminal Area Chart. And you can actually select it up here in this particular program if you want, but it's already on the screen. This is another separate publication that the FAA publishes for major terminal areas. Houston has one. and you can actually see the outline of the map. Houston's terminal area chart is this white outline here. And if you do a lot of flying in the Houston terminal area, which you guys are going to do, you're going to buy one of these charts, or you're going to download it to your iPad, because it's more detailed than the sectional. For instance, you know, I'm looking at the sectional here, but when I switch over to the terminal area chart, you can see it just gets more detailed down at low altitudes. There's more obstructions shown on the chart. There's more what they call jet routes, which are these little pictured jets flying in. You can see more roads, more railroads. It's a lot easier to navigate using the terminal area chart when you have those available. And if I zoom out, you can see which ones are available in the United States. One for every major terminal area: New York, Charlotte, Atlanta. So depending on where you fly, you can get a terminal area chart, and it's much easier to navigate. Here's Los Angeles. And then there's also instrument charts. So when you guys go off into your instrument ratings, you'll use a separate charts for those as well. You've got IFR charts that have instrument, important instrument flying information on it. Some of the other publications that the FAA provides is, I'm going to pull one up right here, the FAA Charts Supplement. And this is a paperback publication that the FAA provides. It's also available on like ForeFlight and stuff like that. But it gives information about, it gives information on airports. So every public use airport and some private airports are in here. And let me pull up a slide. It's easier to see. Here's an example of a chart supplement page. So deeper detail about the airports that you're flying to. It's when you plan across country into another airport, you always review the chart supplement so that you can get information on runway lengths, type of lighting that they use at the airport, frequencies, stuff like that. Very, very good detail that you need for planning your flight. I mean, like I said, some private airports are in the chart supplement. It'll give you instructions on what you need to do to fly into a private airport, like contact the owner at this phone number type thing. So between the sectional and the terminal area chart and the chart supplement, you can successfully plan a cross-country flight and fly a cross-country flight with those 3 FAA publications. You won't, if you're flying VFR, you won't necessarily need instrument charts, and you won't necessarily need instrument procedures. But I have kind of a funny story that I'll tell later in the session regarding a time that I was asked to fly not an instrument procedure, but to use a certain radio fix on an instrument procedure during a VFR flight. So having instrument procedures with you doesn't hurt either, although it's not a requirement. Just one other thing real quick before we go on to the next slide. I want to point out one thing on the sectional here. Let's go back home. And let's get out of the terminal area. One thing that we're going to use in the next exercise are lines of latitude and lines of longitude. The lines of latitude are these horizontal hatched lines that kind of look like a ruler. And the lines of longitude are the horizontal hatched, or I'm sorry, the vertical hatched lines that intersect the lines of latitude. Similar to what you guys learned back in grade school. These lines of latitude and longitude are equally spaced segments that are referenced from true north and give you exact position information. If I can find, sometimes the sectionals are not very good about giving you exactly which degree you're on. But when you can find the actual degrees, minutes, and seconds, you can pinpoint exactly where an airport is or where an obstruction is by just utilizing the latitude and the longitude lines. And we're going to utilize those lines to do our flight planning. It's one of the first steps we use to do our flight planning. So let's go over to that. One other quick point, time zones. I kind of assumed you guys were super familiar with time zones, but I do want to make a couple points. You know, like today, Chris, you're in the Eastern time zone. It should be somewhere in the neighborhood of 2:30 right now. You're an hour ahead of Central. And then, of course, we've got Mountain and Pacific. When we are talking aviation, in the aviation world, the United States time zones are based and referenced from what's called Zulu time, or sometimes you hear it Greenwich Mean Time. It's the absolute 0 point of the 24-hour clock on Earth. East Coast right now is 4 hours because we're in daylight savings, 4 hours behind. Central is 5 hours behind, so on and so forth. Of that Zulu time. So right now, let's see, 2:30 on the East Coast, 3, 4, 5, 6, 6:30 Zulu time is the current Zulu time. And of course, when we're not practicing daylight savings, the East Coast goes 5 hours behind Zulu time. Central is 6 hours, so on and so forth. When you are flying, you always use Zulu time. When you're on Earth, when you're a land creature, you use local time. When you're flying, you use Zulu time. The minute you get into the airplane, everything turns to Zulu time. When you're talking air traffic control, when you're communicating with other pilots, when you're talking to flight service, everything turns to Zulu time, so that everybody is off the same reference. And the reason I had the chart supplement up here with a couple of green boxes is when you look at the chart supplement, everything is also kind of based off of Zulu time. For example, in the airport remarks, they're telling us that no touch and go landings are allowed between 400 and 1200 Zulu. So, you know, as a pilot flying in Texas, I have to mentally calculate what that means to me from a local standpoint. Of course, once I get in the airplane, I'm using Zulu all the time, so I have a better feeling of what that is. And so, as you can see, a lot of the times, I don't see any other times on the chart supplement, but you can see this is an example of time being referenced in Zulu time as opposed to local.
So what would that 400 to 1200 Zulu time be converted to? Is that where you use the UTC offset, or is that 4 a.m. to 12 p.m.?
That is 4 a.m. to 12 p.m. Zulu time.
But Zulu is Greenwich Mean Time, which is over in Europe. Right.
So if we want to convert that to local time, we would have to, because daylight savings time is in effect. For just a second, ignore do you see the crosses right here next to the Z?
I do.
Yeah, ignore that for just 2 seconds. If we're gonna convert 400 Zulu time to local time, because we've got daylight savings time in effect, which we can reference up here in the other green box, -5 daylight savings, then we'll take 4 and we'll subtract 5. So 11 p.m. local time is the time at which I can no longer do touch and go landings.
So 11 p.m. to 7 a.m. No touch and goes. Okay,
That's
cool. That's what I thought. I just wanted to confirm.
Yep. Now, the crosses, because you're going to see this quite a bit too in the publications, the crosses denote that the local time at the airport, or I'm sorry, that the touch and goes in this case are always at the same local time. So in other words, you're not going to adjust this Zulu conversion for daylight savings. Okay? So if those crosses weren't there and you just used Zulu time, then when daylight savings was not in effect, all of a sudden it's 10 p.m. to 6 a.m., right? Because Zulu time does not practice daylight savings.
So by having the crosses, they're saying that it's always 10 p.m. to 6 a.m.
11 p.m. to 7 a.m.
So
always, the crosses essentially, there's two ways you can think about it. The crosses indicate that the restriction is always at the same local time, 11 p.m. to 7 a.m., regardless of whether there's daylight savings time in effect or not.
So which one? So in that case, which one would you know to start the offset with? Because -5 DT is daylight savings time, and -6 is not. Or am I reading that wrong? Because if -5 is daylight savings time, I thought we would use the -6.
You would always use the daylight savings time.
Okay, so the DT.
Mm-hmm.
All right, that makes a lot more sense.
Yep. So, okay. So now you guys remember, so as we go through the slides here, we're going to progressively put together the knowledge required to get a flight plan going on. So I mentioned lines of latitude and longitude earlier. The first thing in planning your flight is charting the course, is what's called putting the course on your chart. And when you start your flight training, you're physically going to draw lines, your flight plan on the chart physically. And you're going to need what's called an aviation plotter to do so. You can get these at Amazon. Quite frankly, I just use a protractor. It's the same damn thing. But you will use this plotter in conjunction with the latitude and longitude lines to figure out angles and to chart the course and determine what direction from true north you're going to be flying. The one assumption that we go in with, which is what I mentioned earlier, the lines of latitude and longitude are based off of true north. So one could say, based on that fact, that the lines of latitude that are horizontally going across the screen are at exactly 090 east relative to true north. And the lines of longitude going up and down the screen are at exactly north 360 and south 180 with regards to true north. So that'll be the reference point we use as we start to chart our course. There's a sequence of calculations that you do, and you don't have to do this on scratch paper or anything. There's actually a table or a spreadsheet that I use and you're going to use. But I'm going to show you the math right here and talk to you about how to chart the course. So using our line of latitude in this case, I'm drawing a line between 2 points, and in reality, I think this is a flight that I planned between Addison Airport in Dallas and West Houston Airport in Houston. And my course line, which is this gray line, intersects a line of latitude right here. I'm going to take my protractor or my plotter, my aviation plotter, and I'm going to determine that the angle here from my line of latitude is, X degrees away from east. And I think the actual course was actually 166 degrees. So if this is 90, right here, straight east, then this course line with this angle here is 166. Makes sense? So we've got essentially, just doing some quick math, I think this is 76 degrees angle, right? You guys follow that?
Yes.
Okay.
I was saying yes, but I was on mute. So
No. I just want to make sure because there's some math involved here. I want to make sure so you essentially, with your course line, which you've already drawn on your chart, because you know where you're starting, you know where you're ending, you determine the angle between a known true course. So my known true course is 90. And my course line is down here. My angle is 76. So I take 90 plus 76. I end up with 166. So what I have determined by doing that activity is that my true course is 166. Okay? True course is defined as your course relative to true north. Very simply put. Now, do you guys remember a couple sessions ago we talked about magnetic variation?
yes.
Okay. Just a quick refresher. Magnetic variation is the difference between difference between your position relative to true north and magnetic north. If you remember, magnetic north is like 1,300 miles away from true north on Earth. And I mentioned that our magnetic variation could be determined by looking at our sectional. Right here, the 3 degrees and 30 minutes east is a magnetic variation for this particular location. It is not the same everywhere, if you remember. In fact, as I travel further west, it should go up. So 5 degrees east as we go out to West Texas. And what I'm going to do is I'm going to add or subtract that variation to my true course. What I'm essentially trying to accomplish here is to get my course from a true reference to true north to a magnetic reference to magnetic north. So I'm going to take my true course, 166. I'm going to introduce magnetic variation to the equation, and I'm going to come up with a magnetic course. Okay? Now, in this particular example, I've got a 3. I'm going to forget about the minutes for simplicity. 3 east. You always subtract easterly variation, and you add westerly. So I'm going to take my 166, I'm going to subtract my 3, and I'm going to have a magnetic course of 163.
Adam, where were you getting the 3 east?
You can't see it on the map. There you can.
Yeah, back here. So let me just, because I'm going to draw my course line I'm using right here. And if you find the magnetic variation on the chart is in a magenta hashed line. So see this magenta hashed line right here, middle of the screen?
Yes.
I'm going to try to find the variation value associated with that line. And sometimes you have to, there it is right there, 3 east.
And that's the closest to where you were planning the course. Because you said that if you go north, it goes more, right?
Correct. You have to use a variation value, or you have to find a magenta hashed variation line near where you're flying. So if you want to get really precise, you would have a different variation value depending on each segment of your flight. So for instance, up here in Dallas, where I start my flight, my variation value is
3 point.
Yeah, 3.5 or 3 degrees 30 minutes. Well, right there.
Okay.
And if where I end my flight, actually, Houston is further east, so I believe it's going to be a little different. Oh, maybe not. It's still 3 degrees. Gosh.
You're always looking for the closest magenta longitude line, and that will tell you your magnetic north.
Exactly. You're looking for the closest magenta. It's called variation line.
Okay.
Mm-hmm. And just from a high level, so we understand why we're doing this, if I were to fly my airplane based on true course, based on the measurement I made from the line of latitude here, I would not be able to use my compass, because my compass references magnetic north. So I have to do the variation calculation.
And this is similar to what the calculation that we did at the, I guess, 3 or 4 classes back when we were charting that course in California?
It's exactly the same. Yep. Okay. Same exact thing.
Okay.
Yep. Because, yeah, for the reason that our airplanes have magnetic compasses and a heading indicator that is calibrated from the magnetic compass, we cannot use true course. Otherwise, we would end up in the wrong location. We have to use magnetic course. And so to do so, we have to introduce this variation equation. Now, this was for a no wind condition. This assumes we have no wind, which is ideal state. Never happens. You always have wind. So what do we do when we have wind? Well, let me just go over a couple wind fundamentals here. As you're flying your airplane on your cross country, you know, you're going to be flying in a direction that gets you to point B. So over here, here's my point B. I want to fly the airplane over there. You're going to point the nose of the aircraft in the direction that gets you to point B. And if you've got no wind, then you'll actually get there. But like I said, that is not the case. You're always going to have wind. And so in this example, if your wind is from the left, if you maintain a heading that gets you to point B, you're actually going to end up over here, you know, several miles away from where you want to be. So what do you want to do? You actually want to put in a correction angle to your heading, so that instead of flying your airplane at a heading that'll get you to point B, with the wind, you actually want to, what we call, crab the airplane into the wind so that it flies in a direction that gets you to point B. And you can see they're doing it down here in this graphic. Here's my point A. In this example, my point A, and here's my point B. So to get to my point B, I actually have to point the nose of the airplane into the wind to get there. Does that make sense to you guys?
Uh-huh.
Okay. So due to this basic phenomenon, we're going to have to do a couple more calculations to ensure we don't end up way off course. We're going to have to implement what's called a wind correction angle. And very simply, we take that wind correction angle and we apply it to our magnetic course, which we just calculated a minute ago. And we end up with a magnetic heading. Now, let me back up, because this is something, I'll be completely honest with you guys, I did not understand. Well, I didn't think about until I actually went to get my commercial rating. Anytime you are making a calculation on these headings, because there's several definitions, right? We've already talked about true course, magnetic course, We're talking now magnetic heading. We're going to talk about compass heading. Anytime we're talking about a course, that is the direction that you intend to fly. Okay? Here's my point A. Here's my point B. My course is the direction I intend to fly. Anytime we're talking a heading, that is the direction your nose is pointed. And the reason it's called a heading is because that's what your magnetic compass is going to say. Your magnetic compass is not going to give you your course. It has no clue what your course is, but it knows which direction your nose is pointed in. Do those two fundamental definitions make sense? Your course is the direction your airplane is going. The heading is the direction. Well, let me say that differently. Course is the path that your airplane is flying. A heading is the direction your nose is pointed in. Makes sense? Does that make sense to everybody?
Yes.
Chris?
Yeah, I mean, you first said course is the direction you intend to fly. But if you're not calculating if you're not pointing towards the wind, if you're not calculating the wind factor, then you're technically, even though you say that's the course I want to fly, you're not flying that course.
That is exactly correct. Yes. And to even take it a step further, if there's zero wind, like if there's no wind, your heading and your course will be the same.
Okay.
Yep. So.
So the way I see it is that the course is where you want to go. The heading is how you're going to get there.
Perfect. Yep, that's exactly right. In order to fly the correct course, you got to point your nose in the proper heading. Oh, okay. And we're going to take one more step here, and we're going to calculate, or we're going to incorporate deviation to get a compass heading. Now, if you guys remember from a couple sessions ago, magnetic deviation is the result of different electric fields in the cockpit adversely impacting your magnetic compass. So for instance, you've got radios, you've got a full electrical system with an alternator, maybe a generator, you've got cell phones, you've got all sorts of crazy electronic devices in your cockpit. And that affects your magnetic compass various degrees. And so you do actually, in practice, have to apply that to your navigation. So we add or subtract the deviation from your magnetic heading to get your compass heading. And your compass heading is what you will fly to get from point A to point B. Because we have incorporated deviation, we've incorporated wind, and we've incorporated magnetic variation. Now, in practice, when you guys get your iPads out and use ForeFlight, or maybe you've got a GPS in the panel, you're not going to do any of this. It's all done for you. But you have to know how the device is doing it. And you have to be able to demonstrate to somebody you know how to do this.
Real quick again, you said the compass heading incorporates wind, magnetic variation, and what was the other one, third component?
Yep. Magnetic variation.
Yeah, and wind. What's the other one?
Deviation.
Deviation, thank you.
And that's going to be found in the manual, correct? Or
mm-hmm. It's actually required.
All the equipment pieces in your plane, right?
It's actually required to be posted under the compass.
Okay, and that can change as you change that equipment, right? So that you may have to update that if the equipment changes.
That's exactly right. Let me pull up a just real quick to jog our memory. Compass deviation card. So this is the little card that is underneath the magnetic compass that basically says, if you want to fly east or 090, you actually have to fly 085. or any a number of different examples here. If you want to fly 300, you actually have to fly 303.
Got it.
Yep. Yep, and here's an example of where it's located on the cockpit. So, in summary, and I'm even going to throw another extra definition in here, so just bear with me. In summary, we're going to start with our true course, which we obtain by measuring our course line from a line of latitude or longitude. We throw in our wind correction angle. Oh, and by the way, I'm putting this up here because there are different ways to get to the final answer, and I do want to show that. So you can actually take, for instance, what I showed earlier. I can take my true course, implement my variation, and get magnetic course. But I can do it in another order too if I want. You can take your true course and put your wind correction angle in, and now you've got a true heading.
Yeah, now you're just talking about the basic properties of math.
Totally right. Or I can flip flop. You know, if I want, I can put magnetic variation in first, and then I'll have magnetic heading, right? Or I'm sorry, magnetic course. All you have to remember is headings deal with the direction your nose is pointed, which of course is impacted by the wind. So once you implement a wind correction angle, we are no longer talking about a course. We are talking about a heading. The words true and magnetic always refer to whether you've implemented your variation or not. So if I haven't implemented my variation adjustment, I'm talking true. If I have, I'm talking magnetic. If I've implemented my wind correction angle, I'm talking heading. If I haven't, I'm talking course. And of course, once we throw deviation in there, it's no longer true or magnetic, it's compass. So far, so good? You guys understand all that kind of math and how you can arrive at the different values?
Yeah. Will deviation always be specific to the aircraft that you're flying?
Absolutely. That's exactly right. Mm-hmm. Okay, and we talked through that. I want to show this to you guys because you'll never see it spelled out like this. Whenever you see it in reference guides or textbooks, or even when you do it for your flight exam, you use these abbreviations. TC is true course, WCA is wind correction angle, variation and deviation don't have acronyms, but this is how you'll kind of see it portrayed.
Got it.
And just another quick note, it's always plus or minus because it can go either direction. If this is my course line, right? That's, I want to get from A to B. And my wind is from this direction. Of course, we've already talked about my airplane. I'm going to have to fly a heading that is into the wind if I want to get to my B destination. So in this case, I'm going to subtract from my course. If the wind was coming from this direction, or I'd be pointed that way, I'd want to add. So you can see how these values can be either added or subtracted depending on which way your wind's coming from, or whether you've got easterly, minus easterly, or plus westerly variation. Okay, makes sense?
Are we going to talk about how to determine the wind correction angle?
Yes.
Okay.
Yeah. Two different ways. The easy way and The easy way, and then the way you're going to be asked to do it on the test. Actually, now that I'm looking around, I need to get my flight calculator to do that. So I'll get that when we get to a break. Okay, kind of a good segue there, Alan. Wind planning. We're going to talk in depth about wind planning and how to get wind conditions, published wind conditions. But I only want to spend like 30 seconds on it during this session because we've got like a whole session on weather planning and how to do flight weather planning. We'll learn how to read these charts. We'll learn how to read the text data, which I've got on the top of the screen here. For the purposes of this session, I just strictly want to make sure we're good at understanding why we have to adjust for the wind and, you know, which direction you have to adjust for, stuff like that. Oh, wow. My assistant has delivered my flight calculator to me.
She is pretty awesome.
Oh, totally awesome. So let's go to, okay. And there we go. Okay, you guys can see me now.
Yes.
Yeah.
So here is the flight computer. Remember the whiz wheel we talked about earlier that you can do all sorts of different calculations on?
Uh-huh.
Here's what I'm going to do. I'm going to kind of show from a high level how you get wind correction angle, but I guarantee you're going to be very displeased with the resolution for which I can actually show it on my camera. So what I'm going to do, Alan, to get our questions answered, I'm going to do an example after class, and I'm going to post it as a separate video. Is that cool?
That's awesome. Yeah. Thank you.
Essentially, what we do, the flight computer has two sides. The spinning side and the what they call the wind planning side. And you essentially go through a series of steps. All this is like a really fancy protractor. It's got angles in it. It's got a compass rose on it. You can see north and east and west. And you go through a series of steps to determine what your wind correction angle is going to be based on known wind speed, known wind direction. So I'll put a separate, maybe a 5-minute video on that after class. I'll post it, and then you guys can, when you get your flight computers, you can practice on the wind calculator. Cool. All right, and before we get into talking some airspace stuff, let me get back to the screen. Just another, now to enter the world of 3 dimensions, because we've been talking headings and courses, to enter the world of 3 dimensions, we have to think about what altitude we're going to fly. When we look at the chart, remember I mentioned that we have to be very cognizant of different obstructions. So for instance, there's an obstruction out here in South Dallas called the Cedar Hill Towers, and it's right here where my pointer is. And they're almost 2,600 feet above sea level. So if your airplane can only fly up to 1,000 feet, you should not fly towards these. And, you know, here in Texas, we really don't have much to worry about from an obstruction standpoint. But when it comes to altitude planning, there are regulations that state which altitude you choose. And the regulations are simply known as the VFR cruising altitudes, Visual Flight Rules cruising altitudes. And it basically says that for magnetic courses on one side of the compass rose, you fly odd altitudes plus 500 feet. And for the other side of the compass rose, you fly even altitudes plus 500 feet. And those directions are 0 to 179 and 180 to 359. So in our example that we've been using in this session, the 166 number, we'd be on the eastern side of this pie, and we would be expected to maintain a cruising altitude of odd plus 500. So 3,500, 5,500, 13,500. These only apply, these regulations on altitude only apply at 3,000 feet and above. So if you're cruising at 1,000 feet, you need not worry about this altitude regulation. Just for curiosity purposes, the reason this regulation is out there is to separate VFR, visual flight rules traffic, and IFR, instrument flight rules traffic. IFR traffic will be using the same odd and even rules, but they won't have the plus 500 feet. They'll just be odd or even altitudes. So 3,000, 5,000 over here, and 4, 6, 8,000 over here. Okay, so we've learned how to chart the course through using our plotter and doing some basic math. Now we have to determine how we're actually going to fly the course. There are two fundamental ways to be a VFR pilot on a VFR cross country. One method is called pilotage, and one is called dead reckoning. And my argument would be, well, let me define them real quick. Pilotage is is flying or getting from point A to point B strictly through the use of ground visual waypoints. So, you know, airports, towers, roads, intersections, stadiums. You're just flying your airplane, looking out the window, and taking note of the visual checkpoints as you fly. And dead reckoning is actually having predetermined points on your map where you have determined the proper headings, distances, and ultimately times to get to each point, so that you can actually mathematically determine when the heck you're going to get to point B. So knowing that, what do you guys think is the safest, best way, or I'll say most popular way to actually fly your course?
Dead reckoning?
I was going to say pilotage.
Oh, we've got a standoff. Please, why do you guys feel?
I want dead reckoning because it seems like it's much more precise and I'll know when I'm going to get there. And it's like planned out versus just kind of guessing on the map.
Okay. Good points. Alan?
So if I understand pilotage correctly, where you're using landmarks along the way, it goes back to my adventure racing days where we had a mantra in the navigation elements of a race which says always stay found. So always know where you are is best to your ability. And with waypoints, you have that ability.
That's an excellent point too. I can't say I disagree with either point, which is why I guess, you know, there's no right or wrong answer, but I'll say that the way that you do it is both. I mean, you use both methods, because if you were to rely just on pilotage, then you don't really have a real good feeling that, you know, you're going to know when you're going to land or how much fuel you're going to have at point B, right? Because you haven't taken the time to do the math and figure out your distances.
Okay, I thought you were still. I thought the A to B to C leg was pilotage because you're not doing a direct shot. I'm going from A to B, then I'm going from B to C.
Yeah, I mean, different definitions, but if you look up the strict definition of pilotage, it's basically flying with your head out the window as landmarks go by.
Oh no, that's not what I was supporting.
No, that's fine. That's fine. And I knew you guys knew the fundamentally correct answer. It truly is. You want to have waypoints so that, to your point, Alan, you know where you're at all the time, right? And you also want to make sure that for each of those waypoints, you've calculated certain parameters so that you know in a pinch, you know, how much longer it's going to take to get there, what heading you need to fly. If you get into an emergency, You want to know the distance to your next waypoint so you can determine if you can even make it there. Stuff like that. So it truly is a combination of the two. And I'm going to show you a spreadsheet that kind of helps answer the question. So this is called a VFR. I call it a VFR Flight Log. I'm sure it's called multiple things, but it essentially helps you organize both pilotage and dead reckoning concepts on a page, and is a way to organize your flight planning. You can see I've got waypoints here. I've got my true course, which we talked about how to find that. I've got a very visual way to determine what my magnetic course is going to be. I've got my wind direction, speed, magnetic variance, and then ultimately my magnetic course. You can see what is the one thing that we just went over a second ago or a couple minutes ago that's not on here?
The variation?
No, variation is right here.
No, the electronic variation.
Deviation. Yep.
Oh, sorry.
Yep.
Yeah, so here's where I get confused. In my world, in the oil and gas world, we always talk about magnetic declination in terms of variation. So I always think of deviation as the magnetic side, and it's a word problem. But yeah, okay. Yeah, the cockpit electronic interference is what I was referring to.
There you go. No problem. I'll be completely honest with you guys. If this tool was 100% accurate, correct, you would have a deviation and a compass heading. Okay? Probably one of the biggest complacency habits that we pilots get into is totally just ignoring deviation. Like, I don't even care because it's only a couple of degrees and my compass jumps all over the place anyway. Right? But if you want to be thorough and you want to be 100% accurate, yeah, you need deviation and compass heading on there.
So do you have is the reason of having different waypoints because once you get to Ray Hubbard, that wind speed could change and you need to calculate a new wind speed in order to get to US 175? You
got it. 100% correct.
Okay.
You're going to have different wind speeds along the entire route. Let me just, because this is great. These are awesome questions. Let's just go here. We're going to go to the Aviation Weather Center and look at a wind map, and we're just going to see for ourselves what the heck's going on in Texas. Not much today, but you can see that if I'm flying in West Texas, the wind's out of the southwest here, Lubbock, southwest, southwest. And if I come over to State or College Station, CLL, it's out of the northeast. So all sorts of changes as you fly from point A to point B. That's absolutely correct. Oh, by the way, the magnetic variation is going to change too, depending where you fly. I mean, if you fly from here to Los Angeles, it's going to go from 4 to like 15 by the time you get there.
So do you have the calculation plotted into the Excel spreadsheet and then it changes once you put the wind speed in there?
Yeah, I think we do. Do we? This particular one only has a formula to calculate the course after variation.
Okay.
But it looks like you're on your own for determining heading, wind direction, and speed. Looks like you're on your own for that. This particular sheet does not automatically calculate, and the reason, probably one of the reasons, is it's such a complex calculation. It's essentially a complex trig problem, trying to determine what your heading would have to be based on wind direction and speed and stuff like that. So to all the points that you guys are making, I would, if this were my sheet, I would make a couple changes because here's my true course. I've got my wind direction and speed. And so knowing that, I'm going to know what my true heading is, right? I'm gonna and you know, I'm not gonna use the true heading column during my flight, but in order to get to my magnetic heading, it just makes it easier. So I'm gonna have my true heading column. I'll fill that out. I've got my variance, so I can get my magnetic course, and all the way down to compass heading. So this particular sheet, you know, the reason the author, I did not make this sheet, so I can't claim to own it. I think the reason the author left these out is they just don't see any value in having the intermediate steps of the calculation on the flight plan. I'll be honest with you guys. You know, I would certainly have a compass heading here, because that's what you need to know to fly your airplane. That is the direction the nose points to get the proper course that you need to go from A to B.
And how do you decide how many waypoints you're going to plot? Is there a typical distance?
So you're really gonna want to pick waypoints that are no further than 20 or 25 nautical miles apart. I'm gonna go over to this particular flight plan I did organize before class. So I'm gonna show it to you on the screen here. And well, we got. Are we not going to show it? Send to map. Okay, here we go. So this particular flight, you can see I've picked waypoints that are essentially pretty close to each other. I'm departing from Addison, and I'm flying out over Lake Ray Hubbard, you know, and that distance is 18 nautical miles. And then my next waypoint down here is probably some road intersection, which is 14. So you can see all my distances over here. I've got a couple 30s, but not many. And the reason you want them so close is because for wind planning purposes, you want to make sure that what you've planned for is reality. So as you're flying, like say I'm flying down here, I get to my Cedar Creek waypoint, and I'm like way off course. I'm like over here, over Enos Airport. Well, then I know I've made some error in my flight planning. I know that I need to correct for my, and 99% of the time it's wind, right? You probably did not make an error in on your plotter or you know, drawing your course line. It's most likely wind. And so if you end up way off course, you're going to want to pull it back to get back on course. And you don't want to go 100 miles before you realize that. Does that make sense?
Yes.
Yeah. Your flight planning log here is going to have a couple other things that I like to see, such as distance and fuel planning. And if you've got distance and speed, you can plan your times. So, you know, for instance, I've got distances here. I've got speed, ground speed here. And so with those two pieces of information, I can plan my times. And I will know, based on each leg, when I'm going to arrive at that waypoint. Chris, another point that you brought up earlier about the winds. If I know my wind at each waypoint, and I know they're going to be different, then I'll know that my speed is different at each waypoint. And we know that because your ground speed is your true airspeed adjusted for wind.
And just so I'm making sure I understand this chart, so that means it's going to take you 7 minutes to get to the first waypoint.
Yeah, if I have my information in here correct, I've got 18 miles. If I go back and check my chart, Yep, 18 nautical miles to the first waypoint. And I'm saying that my true airspeed up here in cell Mike 2 is 135. It's telling me hey, this tool calculates your ground speed. You see this complex trigonometry up here?
Mm-hmm.
So this sheet actually calculates my ground speed for me. The video that I'm going to put together for you guys after class to show you how to use the whiz wheel, you can get ground speed off of that. But this does it for me. It says, hey, Adam, because your wind is out of 341 at 11 knots, your true airspeed is going to be augmented to create a ground speed of 143. And so, Chris, to answer your question, knowing the distance and the speed, I can get my time.
And then can you scroll down because I can't see it. So do you just calculate the whole thing and then you know exactly, or I guess that's part of this tool.
Yeah. So it looks like total time's right up here.
Oh, I see. Okay. They just brought it up to that song. Cool.
Yep. Yeah,
So
and you can see, I mean, I'll just for sake of, but the first several, I've calculated the first several wind data points. Right now, the wind's at my back, and I can tell that because my ground speed's higher than my true airspeed. But let's say the wind was like right at my face, so I'm gonna do like a 120 wind direction. Then you can see my ground speed goes way down compared to my true airspeed.
So is that why when you're flying commercially, they give you the time that you're supposed to get at the airport, but then sometimes it's 30 minutes early just because the wind helped you out?
Absolutely. And I'm telling you guys, after you start learning how to plan flights, it's really the scariest thing. And maybe you're not like this, but you probably are. You'll get to the airport, and the first thing you're going to do is you're going to pull out your ForeFlight and see what kind of winds aloft you got. And you don't even have to be the pilot to know that you're going to get there early.
That's so cool. I was thinking about that because I did 2 different flights this weekend, and I was just wondering why the variances. Figured I had to do something with that. It's fun to learn all of this.
Oh yeah, you'll come right here. You'll come to this tool right here, and you'll even know how to pull up the flight plan. I'm going to show you how to do that next week. And you'll say, well, we're flying at flight level 360, which is 36,000 feet, and there's the wind. So if I'm flying from JFK to Houston, then looks like it's relatively wind free until I get over Tennessee, Alabama, and Arkansas. But then Texas is boring again. So it's probably going to take, standard time. So yeah, you guys will be well equipped to help the pilot plan his flight.
Is it pretentious to offer to help?
Well, those guys, they don't go into this level of detail. Someone hands them their flight plan and says, "Sir or ma'am, it's going to take you this long to get there." They're very boring. So. Anyway, so yeah, I pulled this up. Guys, there's all sorts of tools on the internet. I like this one because it's got what I'll say just the right stuff on it. You don't need all the extra crap. There's tools out there. There's all sorts of, has all sorts of stuff on it, but this has just what you need. Your flight instructor and your flight school may have their own format. I have no idea. But this is something similar to what I used when I started to fly. It's got all the stuff on it that you need.
I'm sorry, just don't want to slow everyone down, but the wind direction, where are you getting that number?
So you can get it from a number of different areas. As an example, here on the Aviation Weather Center, aviationweather.gov, the National Weather Service publishes wind data. So if I come down here to winds, just one example, the text version, which is the version you'll be expected to learn, is available on this website. And I'm just going to make it real easy. Let's go to, I think Houston uses Hobby. Yeah, here it is, Houston Hobby, right there. See the airport code, Houston Hobby? Mm-hmm. So essentially, this is a text string of wind data. And it's by flight level. So this is very rudimentary, but these are in columns. So here's the 3,000 foot column right here, the 6,000 foot column, the 9,000 foot column, so on and so forth. And so if I go down to Houston Hobby, I'm just going to focus on the first two columns, 3,000 and 6,000. You've got some numerical text strings. And essentially what this is telling me, and we'll get more into this in the weather session, but this tells me that the winds are out of a direction of 040, so out of the northeast, at a speed of 0.6 knots. And at 6,000 feet, they're at a direction of 350 at 14 knots. And then this plus 17 is just the ambient temperature, plus 17 degrees Celsius.
So they never go below, they never go to the ones digit for headings? Like you would never see a 042?
No, they don't.
It's going to be 040? Okay.
Yeah. Yeah, they don't do that, probably because it's not that accurate, or it's not as, the resolution of the data is not that good. This is
Sure.
The way they get this is they send up a weather balloon over Houston Airport, and they plot the winds every 6 hours or so.
Oh, wow.
Yeah. And this data, I mean, again, you'll be expected to know this for your flight test, but I'll be honest with you guys, if I'm looking for wind data, I'm taking the lazy man's method. I'm going up to this map, and I'm like, all right, where am I flying today? College Station. All right, my wind is 30 at 5 knots.
Awesome.
Yeah, it's by the way, ForeFlight, if you decide to use ForeFlight, it calculates it for you. Don't even have to look at the winds. You just go to your nav log. Is it going to let me see it? It's because my flight's too. Let me start a new flight just for kicks. I'm going to go from Addison to Philadelphia. And I think it's going to just calculate it for me. How do I adjust that? What the shoot?
So while you're doing that, I'll ask you a side question. On the previous map where you showed the wind indication for College Station that said, 5 knots from 30 degrees, is the direction of the line the way the wind is blowing?
It's the direction that it's coming from. Right.
So it's coming from the northeast into College Station on a roughly 30 degrees at 5 knots. Is that right?
That's right. Yeah. If you were looking northeast, the wind would be blowing in your face.
Okay. Cool. Got it. And the tail,
the little spoke at the end is where the wind's coming into.
So the little spoke on the end of the line, like that little barb.
Yeah.
Is an indicator of how fast the wind is going.
Oh.
So one small spoke is 5 knots. A long spoke is 10 knots. And a triangle barb is 30 knots. And there's a little, I just saw this. There's a little legend down here. Actually, the barb might not be 30 knots. The barb might be something different. But you see that little triangle barb?
Mm-hmm.
Yeah. So the number of barbs that the line has denotes speed. So if we go, let's see, somewhere's getting some higher wind. So we got some higher wind up here. So this one, if I know what I'm talking about, should be 10, 20, 30, 40 knots maybe? Yeah, 41 knots.
We'll be flying in there anytime soon.
That's pretty fast, yeah. So back at ForeFlight, so if you're, when you guys become proficient and you're comfortable with wind planning, you don't feel like doing it yourself, this program will just do it for you based on your headings, and I obviously can't get it to work. So I must be doing something wrong. Send to flights. Oh, okay, here we go. I don't use the web version that much. I use it on my iPad. So here we go. Anyway, it does it for you. It'll basically take all the wind stations along your routed flight, and correct all your headings for you and give you your different ground speeds. It's pretty sweet.
Wow.
Yeah. So, okay. So we went over the flight log, doing a time check, about a half hour. I think we're doing decent on time. Any other, any questions on the math, on like the headings and stuff?
No, I'm just gonna have to practice that.
Yeah.
Yeah, same here.
Yeah. Okay. So let's just introduce airspace. I'm gonna have another time slot in the next session to continue airspace discussions. It's not possible to cover it all in one session. So for this particular session, I want to cover airspace relative to airports. There's airspace discussions for areas away from airports. But I'll say probably the more important, or maybe not more important, but probably the very important airspace discussion is airport airspace. So we're gonna start from, I'll say, the highest altitude and the most probably controlled airspaces, and then we'll boil it down to the least controlled airspaces and stuff like that. Some things to keep in mind when you talk about airspace is the type of equipment that you have in your aircraft. As a VFR pilot, a visual flight rules pilot, you're going to want to know whether or not you are legally allowed to operate in the airspace that you're flying through. And there's kind of three fundamental equipment considerations that you want to keep in mind. One is a transponder. Transponder is a device in your aircraft that picks up and emits the proper signals for a radar system to see your aircraft. Without a transponder in your airplane, air traffic control would have to rely on the radar signal physically hitting your aircraft and putting up a little symbol on their radar screen. And that's not a very high fidelity way to track airplanes. So for that reason, our airplanes have what are called transponders. They can be as simple as just a device that emits the proper radar signal, or they could be fancy and be able to tell the controller, what kind of airplane you are, what your registration number is, how fast you're flying, all that good stuff. Another piece of equipment that you're going to want to know about in the airplane is your altimeter. 99% of altimeters out there are what we call encoding altimeters, which means they communicate to the transponder what your altitude is, how high you're flying. And that in turn communicates back to air traffic control what your altitude is. And then your two-way radio is the third piece of equipment, which of course is the way that you communicate to air traffic control. So we're going to start way up high and talk about Class Alpha airspace. This airspace is between flight level 180 and flight level 600. When we get above 18,000 feet, we no longer use the terms 1,000 feet. We use the term flight level. So flight level 180 would be 18,000 feet technically, and flight level 600 is 60,000 feet. All airspace above flight level 600 is for the space shuttle, and we don't really worry about that. Some important points about Class Alpha. It is air traffic controlled. You always have to be talking to air traffic control while you're in this airspace. You will always have your altimeter set to 29 or 9 or 2. That is so that every aircraft is on a standard datum plane. If you guys remember that term from last class.
Mm-hmm.
And you have to be on an IFR flight plan. You cannot be a VFR pilot. You cannot be flying VFR. You have to be on an IFR flight plan under air traffic control. So for that reason, VFR pilots like me and you guys, we don't fly up there. We are not qualified. Typically we don't have the right equipment. We don't have the right aircraft. But if we're VFR, we don't fly up there. You do have to have a two-way radio, a transponder, and you also have to have a technology called Automatic Data Surveillance, ADS. I won't get into that too much. You can do some research on your own, but it's a special kind of transponder that gives air traffic control a ton more information than a typical transponder. Not just position information, but type of aircraft, altitude, speed, how many people are on board your aircraft, the whole deal. So this is the most restricted type of airspace that we deal with. We're going to step down to another type of, I'll say, busy, restrictive airspace, Class Bravo, Class B airspace. There is only, I think, 12 or 13 Class Bravo airspaces in the United States, and they are surrounding all of the busy terminal areas that we know about, like Houston, DFW, Chicago, New York City. This airspace allows air traffic control to separate large commercial transport traffic from the little guys like us. And and it's a restrictive airspace. It's the biggest type of airport airspace there is. When you look at the airspace from the side, as you're flying your airplane, it looks like an upside down wedding cake. If you guys know what wedding cakes look like, this is kind of an upside down wedding cake. It allows for what we call step down procedures for the commercial transport traffic. They can fly in from a high altitude, and as they get close to the airport, they can step down to landing. It also allows little guys like us the ability to fly, underneath the shelf of the wedding cake. Let's go over here really quick. I want to show this on the on the map. So here is Houston Bush Intercontinental, which you guys are probably extremely familiar with. And the Class B airspace is denoted with the blue circles going around the immediate airspace area. And then the concentric circles that are inside the outer ring, like the blue ring here and the blue ring. See the blue rings as you get closer?
Mm-hmm. Is that the cake? That's
the cake. Those are the step downs. So more specifically, the first shelf. Oh, by the way, the cake, the top of the cake or the bottom of the cake, depending on how you want to look at it, is at 10,000 feet. Right here. See this fraction, 100 over 40?
Mm-hmm.
So that means that the top of that particular shelf is at 10,000 feet, and the bottom of the shelf is at 4,000. The next step down goes down to 3,000. See that shelf notation?
Mm-hmm.
Then the next one is 2,000. And then the next one is surface, SFC.
So if I'm reading this correctly, let's say where the 100 over 20 is, there's the North Houston Airport. As a VFR pilot, I could be in that, so move your mount, your put her down, yeah, right there. I can fly in that airspace as long as I'm at 2,000 feet or below.
That's exactly right.
And if I wanted to go higher, I would need to go out to the next ring, and then I could go to 3,000 feet, then 4,000, and then eventually I leave the airspace.
That's exactly right.
Okay.
Chris, does that visually make sense to you?
Yes.
Okay.
So my next question is, in here, they're not just circles. There are these horizontal lines that meet an arc and then meet another horizontal line. Does that just change the shape of the cake?
It changes the shape of the cake. It's also a very good point, because what I should have said earlier is, yes, it's a good way to visualize this as an upside down wedding cake, but each particular terminal area has variation. Houston, for example, it's got these corridors, these east-west corridors here, which allow for landing and departing traffic on the east-west runways.
That was going to be my next question. Is that to change the way the flights approach the airport?
That's exactly how. Yep. Let me go out to LAX real quick. You'll notice in Los Angeles, it's not even a circle. It's like it's a, I don't even know what to call this.
It's LA. They do everything different.
Yeah, that's right. It's all screwed up. Yeah.
Their air traffic looks like their road traffic.
So
no, it's totally right. Yeah. No, they generally are circles, but they cater them for the specific runway configuration stuff. Yeah.
You're getting ahead there. I saw there was also a Magenta Airspace in LA, outside of LAX. Guessing that is a different type of airspace.
It is. Yes. Okay. Great. It's the next one we're going to talk about.
Awesome. Well, I'll wait for that then.
Okay. Well, let me just clear a couple points here before I get there. Class Bravo, something we got to remember just for your training and for the written test. You do have to meet certain pilot qualifications to operate inside a Class Bravo. Those are, you have to be a private pilot, at least a private pilot. If you're not a private pilot, if you're a student pilot, you have to have your instructor give you a endorsement every 90 days. Specific for that airspace. So if I'm a student and I want to fly in the DFW Class Bravo, my instructor has to say Adam Roberts has shown proficiency in operating in the DFW Class Bravo airspace signature. So either you've got an endorsement or you are a certificated private pilot or above. And you also have to receive a clearance to enter the airspace. You physically have to hear air traffic control say, November 1, 2, 3, 4, cleared Class Bravo. If you don't hear those words, you cannot enter the airspace. And from an equipment perspective, it is the most restrictive. You need a two-way radio. You need a transponder within 30 nautical miles of the airport, of the main airport, Class B airport. You also need a transponder above the airspace. So, in the case of IAH, you need above 10,000 feet, above the entire wedding cake. You also need an encoding altimeter. So your altimeter must be able to communicate altitude to air traffic control. So this is the most restrictive airspace, and for good reason. You've got a lot of heavy aircraft, big jets in and out. All right, Class Charlie. Class Charlie airspace is from a complexity and busyness standpoint, the next step down. These are, I think the exact number is like 40. There's like 40 Class Charlie airspaces. Don't quote me on that. I need to look that up. But there's very few examples in Texas. San Antonio is a Class Charlie, surprisingly enough. And it is, to Alan's point, denoted with a magenta, solid, circular airspace structure on the chart. And in general, this isn't a rule, but in general, you will always have a ceiling or a top surface of 4,800 feet above sea level, the 48, and a single shelf, which is 2,000 feet above sea level. And the airspace conceptually, visually looks like this. I guess still kind of an upside down wedding cake depending on how big your cake is.
Like a bolt.
That's right. The Class Charlie geometries are more standard than the Class Bravo. They typically have a 10 nautical mile radius top shelf and a 5 nautical mile radius bottom. And like I said, they typically have these standard altitudes either above ground or above sea level. These particular ones are AGL, 4,000 feet AGL, 1,200 feet AGL. There are no minimum pilot qualifications. You can fly in and out of these airports regardless of whether you're a student, private pilot, or anything. Now, the difference between Bravo and Charlie, you have to contact air traffic control in both cases. But Charlie, you don't have to receive a clearance. You just have to make positive contact. So for example, in Bravo, I said you have to hear the words, November 1, 2, 3, 4, cleared into the class Bravo. For class Charlie, you simply have to hear November 1, 2, 3, 4, Roger, radio contact or radar contact. That's it. They don't have to give you a clearance.
How does that work though? If there's multiple airplanes coming into the air, I mean, isn't that the whole reason why you have air traffic control, to tell you when your turn is?
Yeah, but they cannot. The only way they can keep you from flying into the airspace is if they verbally tell you to not enter the airspace. Air traffic control reserves the right to say, November 1, 2, 3, 4, stay clear of the class Charlie, stand by for further instruction. But they do not have to give you a clearance. They can simply acknowledge your radio transmission, and that's all you need to enter the airspace. And to answer your question further, class Charlie just is not as busy. So they don't have the requirement of actually giving you a clearance.
But how do you know when it's safe to land?
You have to receive a landing clearance. So that is one thing, regardless of which airspace you're in. Well, let me back up. If you're landing at a controlled airport, an airport that has a blue outline, like San Antonio and Randolph Air Force Base and New Braunfels, then you have to receive a landing clearance from the controller. But in the case of San Antonio, he doesn't have to give you a clearance to enter the airspace, to actually go into the Magenta area.
Got it. Okay.
Yep.
That's helpful.
So as you're approaching the airspace, you're going to say, and just do it as an example, San Antonio approach, November 1, 2, 3, 4 is 10 miles to the east, inbound for landing San Antonio. And then the controller's going to say, Roger, November 1, 2, 3, 4, San Antonio approach, San Antonio altimeter 29902, advise when you have the field in sight. And that is enough radio transmission for you to legally enter the airspace. Now, it's not enough to clear you to land, but you just received enough radio transmission to enter.
Got it.
Because you could just be flying through, right?
Oh, amen. In 99% of the time you are. You're flying from New Braunfels to Casterville. And you're, San Antonio approach, November 1, 2, 3, 4, 10 miles to the east, transitioning your airspace, direct Casterville. And they'll say, Roger, November 1, 2, 3, 4, San Antonio approach, radar contact, 10 miles to the east, state when you're clear of my airspace or whatever.
Got it.
So are you trying to plan your waypoints outside of these clearance areas?
It really depends. I hate to give an answer like it really depends, but if I'll give two examples. Let's say I am going to plan a flight from New Braunfels to Casterville. Okay. With Class Charlie airspace, it's actually extremely important that you get on the frequency with air traffic control for safety reasons, because they're vectoring still San Antonio. If you guys have been to that airport, it's still a commercial airport. They're vectoring 737s, A320s in and out of there all the time. So if you're flying straight through, you're going to want to be on their frequency just for safety reasons. Now, if you fly above 4,800 feet, you legally don't have to be. You don't have to talk to anyone. But I can tell you that for safety purposes, air traffic control is going to want to talk to you.
State your intentions.
Absolutely, yeah. There a lot of the, and I'm the same way. When I started to learn how to fly, air traffic control it's a little intimidating.
Yeah.
Everybody's talking fast. Like, if you screw up, they're like, WTF, can you hear me?
That's why I've been watching those videos, just trying to get a sense of some of it's so fast. I mean, it's literally so fast. It scares the heck out of me.
Yeah.
But otherwise, you can always ask for clarification. Like,
1,
2, 3, 4, seeking clarification, ATC.
Yeah, and the worst thing that's going to happen is they're going to tell you that you can't go on your straight path. I mean, 99 times out of 10, they're going to acknowledge you, give you an altimeter setting, and give you traffic advisories. Like, November 1, 2, 3, 4, traffic advisory, 2 o'clock, 7:37, report in sight, So it's nothing to be worried about. Now, I'll give another example. The flight that I planned to West Houston, if you guys remember, it was actually from Addison to West Houston by way of Lake Ray Hubbard, remember?
Mm-hmm.
And the reason I did that is because based on the close proximity of Addison Airport, which is right here, to the Class Bravo, I didn't want to have to get a Class Bravo clearance in less than like 2 miles. You can see the Class Bravo shelf for 2,000 feet is like right there. And so my personal preference is after departure, left-hand turn towards Lake Ray Hubbard. And I'm just going to stay below the Bravo. I'm going to stay below 3,000 feet in this quadrant. And I'm going to stay below 4,000 feet in this quadrant right here. I'm just not going to talk to, air traffic control. I'm just going to stay below it. Now, alternatively, I could, while I'm on the ground in Addison, request from the Addison control tower what's called Vfr Flight Following, which I'm going to get into in the next session next week. And they will issue me a transponder code. And I'll punch that transponder code into my transponder. And then after I depart Addison, I contact approach control and say, DFW approach, November 1, 2, 3, 4, with you, 1,000 feet, just departed Addison. And then they'll say, November 1, 2, 3, 4, DFW approach, radar contact, Addison Airport, cleared into the Bravo airspace, maintain heading 180. And at that point, I'm at the mercy of air traffic control. They tell me where I go, what heading, what altitude, you name it. So I could have done that, but to me, it's like way easier to just, fly to Lake Ray Hubbard and then fly south. Make sense?
Yeah. Of all the lessons we've had so far, this one wants me. This makes me want to get in a cockpit so bad.
Oh yeah. Now once you start talking about planning flights, man, it's nuts. You just want to go places. So we talked about two-way radio communication required on Class C. Also, like I said, and this isn't a regulation, but the Airman's Information Manual, the AIM, specifically states that VFR participation via two-way radio is encouraged within 20 miles of a Class C airport. Just because these are the airports that the FAA says aren't busy enough to be Class B, but they're pretty damn busy. I mean, if you guys have been to any of these airports, there's flights coming in and out all the time. Austin Bergstrom is a Class C. So, and then we've got Class D, Class Delta. It is the smallest controlled airspace for a air traffic controlled airport. And examples of this, around where you guys are at, Houston Executive, Sugarland. You can see it is denoted with a blue hashed line. circular blue hash circle, which denotes the airspace, and it is simply a cylinder with a ceiling. And that ceiling is, in the case of Houston Executive, 2,500 feet above sea level is the ceiling of that, cylinder minus that little cutout. And so for Class Delta is extremely similar to Class Charlie. You do have to obtain radio transmission. You do have to have someone from air traffic control acknowledge you, but you do not need a clearance. And with Class Delta, you definitely want to check the Charts Supplement, that book I told you about with all the airport information, because typically the tower controllers are not full-time. They're not 24 hours. They're typically just, 6 a.m. to midnight or some such thing. So Delta's the easiest of the towered airports to get in and out of because it's not as busy, not as many airplanes flying in and out. And then we got Class E. I'm going to try to talk about Class E here in the 3 minutes we have left, but there's definitely going to be some carryover into next class. Class Echo is all airspace. I'm going to describe this in layman's terms and then get more technical. Class Echo is all airspace in the United States below 18,000 feet that is not Class B, C, D, or G. And we haven't talked G yet, but we talked B, C, and D. So literally, the easiest way to think about Class E is it's like everywhere. It's like, literally, Class E is basically everywhere you fly. Air traffic control services are provided, but they are not mandatory. You do not need a clearance. You do have to have a transponder above 10,000 feet in Class E. And then, Chris, you had mentioned earlier in the session about the magenta lines around some of the airports.
Uh-huh.
So this is where Class E comes. This is probably where you'll interface with Class E the most. So Class E, the geometries and the altitudes with Class E are either down to 700 feet above the ground, down to 1,200 feet above the ground, or in some extremely, extremely rare circumstances, only down to 14,500 feet above the ground. And where Class E terminates, it becomes Class G. And Class Golf, Class G, is uncontrolled, no air traffic control, no traffic separation, none of that. Everybody's on their own. So, if I look on the map, the magenta line surrounding the airport, this particular airport, everything inside the line I'll say to the inside of the faded portion. Can you guys see on the screen how it fades?
Yeah.
Yes.
So everything to the inside of the faded portion is Class G below 700 feet. So in other words, that is this airport right here. It's Class G from the ground up to 700, and then it's Class E everywhere above it. Everywhere above this airport in this area is Class E above 700 feet. Outside of the circle, to the non-faded side, Class G extends up to 1,200 feet. So for instance, Wells Airport 66 Romeo doesn't have the circle, so its Class E starts at 1,200 feet. So that's this airport right here.
So the one with the magenta is 700 without the magenta circle is 1,200.
Exactly.
Meaning that
Again, you can think about this in the wedding cake shelf scenario. This shelf is 700 feet, okay? And this shelf is 1,200 feet out here by Wells.
And yeah.
And the ceiling of Class Echo, Class E, is 17,999 feet. So you get the impression how basically every airspace you fly through is Class E.
Mm-hmm.
Except when you go to land at one of the magenta colored airports. Because when I land at Wells, I'm going to be Class Echo until I get down to 1,200 feet. Then all of a sudden I'm Class Golf. And for Eagle Lake, I'm Class Echo until I get down to 700 feet, and then I'm Class Golf. And so for that reason, you're going to hear the Magenta airports described as Class G airports. Whenever you hear somebody say a Class G airport, it's one of these Magenta airports. No control tower, no air traffic control. All safety and traffic separation is up to the individual pilots using the airport. Now, before we wrap up, I just want to show one more thing. Just go a couple minutes. Are you guys good to go over just 30 more seconds?
Yeah.
Yeah.
Okay. Now, Class E, we talked 700 feet and 1,200 foot floor of Class C is extremely common. I don't think in my entire life have I ever flown over a 14,500 foot Class Echo floor, but it does exist in Montana. It exists in Montana and Idaho. Here is a Class E floor at 14,500. Inside the blue line here, this is really blue. It doesn't look like it, but it's blue. Inside the, on the solid side of the line, the floor is 14,500. And everywhere inside this little shape is Class G below there. On the faded side of the line, outside of the shape, it goes all the way down to 1,200.
Okay, run that. So on the inside of the non-faded line is where the 14.5 line?
14.5, you got it.
Okay. And
So
is that just because of the what's inside that box?
Yeah, who knows, right? I'm not sure what, 9 times out of 10, the reason that Class Echo only goes down to 14.5 is because air traffic control has no way of monitoring your progress. There might be like a radar issue or a two-way radio issue, like a transmission issue, maybe caused by these mountains.
So just to be clear, it's not that you need clearance to be below 14,500. It's that you then go into Class G airspace, which we haven't specifically defined yet.
Well, Class G is any airspace that's not controlled, that does not have air traffic control services.
Okay, I missed that. Okay.
Yeah. Mm-hmm.
So it's kind of like swim at your own risk at that point.
It absolutely is.
Got it.
If you're flying, just to make an example, if you're flying through this airspace and you're on a flight plan and you've got air traffic control services, as soon as you hit, let's say you're flying west to east, as soon as you hit, Cougar Canyon Wilderness area, air traffic control is going to come across and say, November 1, 2, 3, 4, you are approaching a break in the Class E airspace. Radar services terminated. Contact me when you're back in Class E. And so you're gonna fly through the Class G. You're gonna putt your way through the Class G, and when you're on the other side, when you get to Canaraville, you're gonna contact them back and say, air traffic control, November 1, 2, 3, 4, we're back into Class Echo, request radar services. And then they'll get you back online.
Got it.
Yep.
So in the spots they physically can't give you radar control? Is that why that is? I'm still trying to understand.
Yeah, 9 times out of 10, it's because for some reason they can no longer get you on radar. It's usually because of terrain. Or two-way radio communications. They can't keep you on two-way radio because two of the primary requirements for air traffic control is that they can see you and that they can talk to you.
Okay.
Yeah, and so 9 times out of 10, the reason that you'll have a void in Class E, where the floor is 14.5, is because they have no way of maintaining communications or contact with you.
Okay.
Yep. The same thing goes for, I mean, it's the same concept as the airports. When you're flying along, let's say you're flying to Eagle Lake, and you're on approach, and you're with air traffic control. Let's say you're getting flight following or radar services, which we're going to talk about in a future session. As soon as you get to that magenta line, they're going to contact you and say, November 1, 2, 3, 4, you are leaving my airspace, because he sees you're getting to the Class G airspace because you're down at 700 feet and you're going into Class G. He's going to tell you, you're leaving my airspace. Radar services are terminated. You know, frequency change approved. And then you're gonna respond, copy that, frequency change approved. Thanks for your help.
It's like a handoff, right? At that point.
Yeah. For the sole reason that air traffic control cannot control you or give you any sort of services in Class G, only in Class E.
Got it.
Yep. Yeah, Class E gets a little confusing, but it's just important to keep in mind it's 99% of the airspace we fly through. I mean, in my flight from Addison to West Houston, I mean, I'm in Class E like the whole damn time. I only leave Class E when I land at West Houston. When I get down to, well, no, according to this map, it goes all the way down to 700 feet. Because why? Look at the magenta line. The magenta line goes all the way around the terminal area. So Class E terminates at 700 feet in this huge shape. You guys see that?
Yeah. Quick question. What are the magenta circle lines? When there's a blue line already.
Yeah, where are you seeing that? Because that's a good question.
I wish I could point on it, but like take the large blue line, the outside line, and then there's, you know, towards the top it says like mode. And then
okay. Yep. So you remember how I mentioned? Let me get to a good spot here. Yeah, mode C. So you know how I mentioned that a transponder with an encoding altimeter is required for Class Bravo?
Yeah.
So for most of the Class Bravo terminal areas, not only do you have to have a transponder with an encoding altimeter to operate inside the airspace, but they want you to have that equipment inside what's called a Mode C veil. So not only inside the airspace, but anytime you're within 30 nautical miles of the primary airport. So for instance, Houston, the primary airport is Bush Intercontinental. The FAA has determined that they want you to have a transponder with an encoding altimeter, which is essentially what Mode C means. Everywhere, from the surface all the way up through to, in this case, I think it's 14,000 feet inside this magenta circle.
Okay.
Yep. And let me see if I'll go to like Atlanta. Yep, same thing with Atlanta. So they've got a Mode C veil. So if you're flying inside that circle at any altitude, you've got to have an encoding altimeter and a transponder.
Okay.
Which, I mean, I'd venture to say that like the Luscombe that that your cousins fly, Alan, they probably don't have an encoding altimeter, but the airplanes that you guys are going to fly in your training will definitely have that equipment.
So a quick question while we're here.
Yep.
The direction of the fade is meaningful. Could you run through that one more time?
Yep. So for Class E, we'll use these airports here. So for Class Echo, if the fade in the direction of the fade, that is the lower altitude. So that means Class Echo terminates at 700 feet.
Oh, and that's why the other one, the fade, was in the opposite direction, because it terminated at 1,200 feet versus back up in Montana. That one, the fade was the opposite direction.
Yep. KSGH. Oh. Shit. What was it? SGU. That was it. Oh, it's actually in Salt Lake. It's near Salt Lake City, actually. Yeah. So in this case, for the blue line, which is denoting the termination of Class Echo at the higher altitude, the solid, the side to the airspace to the solid side is 14,500 floor. And then the side to the fade is 1,200.
Okay. So that's just for Class G?
That separates, yes, that separates Class Echo from Class G, correct.
So, okay, so now I think I understand. So inside the blue box is Class G space?
Below 14.5.
Right. So what the fade indicates is you're transitioning from a Class E of 1,200 to a Class E of 14.5 in order to maintain Class E space. Versus on the red just to the next of it, you're transitioning from Class E to Class G, going from higher down to 700 square feet. Sorry.
That's absolutely correct.
AGL. Okay, I think I get it now.
Yeah. So
the direction of the change of the airspace.
So if we take this particular, this is actually a really good spot. Let's pretend like we're flying, we're right here. See this word towers?
Mm-hmm.
So essentially, if we're flying into that airspace to the right, we're going from, the airplane's basically going from here to here.
Right.
Right. And as we continue and go towards this airport, we're essentially flying back out of the 14.5 area into the 1,200 area, and then approaching an airport that has a floor of 700. So we're basically then going to a 700 floor.
Got it. That makes sense.
Yep. And just one more item, because again, all this is highly involved. If the Magenta non-controlled airport has a magenta dotted line, as if we all thought that we were finished talking about airspace, then that means that the Class Echo goes all the way to the ground. It doesn't stop at 700 feet. Essentially, it goes down to 700 feet when you go into the faded portion here. And then as you transition across the dotted line, it then goes all the way to the ground.
So let's say you're flying. Okay, you see the paperclip on the northeast quadrant, right outside the blue line.
Right there. Mm-hmm.
Yeah. So if you're flying here and you're at 600 feet AGL, you're in Class G space. And then let's say as soon as you cross the dotted line headed towards St. George Regional, you go right back into Class E, even though you're still at 600 feet.
Correct. And you'll be in Class C until you touch the ground.
Got it. Okay. Is that because it's a tower controlled?
Couple reasons. One, it might have a part-time control tower, but not likely, because those typically will be blue.
That's right. Okay.
Yep. But I've seen it. Actually West Houston, not West Houston, Houston Executive. It's either Houston Executive or Sugarland Regional. Used to be the same thing as St. George. It used to be a magenta with a magenta dotted circle. It since has become a full-time Class Delta. But your assessment is correct. You will fly at 600 feet in Class G at the paperclip, which is really a racetrack.
Oh.
Yeah, and then you will enter Class E again when you go through that dotted line. Correct.
So what would convert that airspace back to an E if it's not if it's an uncontrolled air tower?
Say that again. What would convert it? What?
Yeah. What would suddenly make that airport a Class E all the way down to the surface if it's not controlled?
Because air traffic control, for some reason, and I'll give the 99% reason in a second here. Air traffic control, for some reason, wants to have control authority, i.e., radar coverage and two-way radio communications for that airport all the way to the ground.
Got it. Okay.
Yep. Whereas with a regular Class G airport like Mesquite down here, they're comfortable with just terminating radar services as soon as you hit the 700-foot mark.
Okay.
Yeah.
What does parachute mean?
It means that parachute operations are typical at that airport, like skydiving.
Okay.
Yep.
Don't hit the skydivers.
Don't hit the, yeah. Oh, yeah. Yeah, and so what you guys actually notice when you guys go off into your instrument training is that these magenta lines are non-circular because of the instrument approaches. See the runway, and then you've got the instrument approach inside this magenta box. So air traffic control wants control authority over your aircraft if you're on an instrument flight plan down to 700 feet at least as you are on this glide path.
Got it.
Yep. So that's Class Echo and Class Golf. And there is a lot more to talk about with regard to airspace. Each airspace has specific weather requirements that you must meet to determine whether you're visual or instrument. We'll get into that next class. And then there's other kinds of airspace like restricted, military, prohibited, etc. We'll talk about that next time. So what questions do you have about airspace, about some of the preliminary flight planning that we talked about?
How do you study for that? I mean, maybe I just need to see the practice questions, and then I think from there I'll have questions on the best way to study, because I'm guessing, like you said, there's hundreds of pieces of detail on those maps, but for the stage that the VFR pilot license we're looking at, probably only have to know a handful of them. Are they going to give us a map and ask us to identify certain elements, or to actually plot a route and then calculate all the different legs?
Yeah, I think it's two things. Number one, just logistically, you could take time studying the sectional legend, which is like right here on the screen, if you wanted to. But your second point was spot on. Once we go through the next couple sessions, you'll be greatly benefited by actually sitting down and planning flights. Like literally sitting down, going through the motions of planning a complete flight, from finding your true course to getting your compass heading to checking for obstructions, checking the weather, and then filling out your flight log. And then and so each way across your course, you'll come up to different airspaces and different obstructions. And we haven't even gotten into air traffic control. Once we start talking about how you engage air traffic control in your flight, then you're going to be thinking like, oh shoot, well, what frequency do I need to know during this part of the flight, and who do I contact? And yeah, so actually sitting down and planning the flights as if you're actually going to fly it is like really, really practical.
And would you suggest going and I guess maybe ordering some of the sectionals and sitting down with a pencil and eraser and just iterating?
Oh yeah, absolutely. From this class forward, I would go to your local airport and buy some aviation sectionals. I think you can buy them online at the FAA's website, but they might be a little cheaper if you just go to the airport. And I'll put in an email which ones you should purchase. Yeah, which ones are the best ones to purchase. I'm also going to give you guys, we're definitely at the right time in the course for you to order a flight computer and a plotter if you don't want to use a protractor. So yeah, I'll put that in an email so that you guys can start, putting pencil to paper and pretending like you're actually going to plan a flight out. And, for the written test, there's definitely, you want to get prepped for the written test for sure. And then once you start your flight training, going through some of this practice is just going to make it a lot easier to focus on how to fly the airplane. I always found it difficult because I didn't do I did some ground school, but it wasn't this involved. I found it kind of challenging to learn this stuff, like the flight planning and like the logistical activities around weather and air traffic control. It was tough to learn that and learn how to fly the airplane at the same time.
Right.
So trying to get one of these down while we don't, we're not flying airplanes right now can be really helpful.
I like it.
Yep. Chris, anything on your end? Any questions or?
So I understand for what we're doing right now and the course that we're doing now in the test, that it's basically this course, studying, taking the written test, and then getting 50 hours of flight. What does it look like for the one passing the both written and physical tests? What is it for the IFR?
So the IFR rating is a completely separate rating, but in my opinion, regardless of what kind of flying you're going to do, I would totally recommend it. It's a huge insurance policy. It makes you a million times better pilot. And what's involved is about, I don't know the minimum hours, but it's about another 30 hours of flying. 30. I think I actually took like 40. But it is a handful of hours, and you will be doing nothing but flying under the hood, meaning flying with a view limiting device, pretending like you're flying in bad weather the whole time. And then you will take a written test. There is a instrument pilot written test that is similar to the preparation for the private pilot test. And then you will take an instrument pilot flight test, which again is very similar to the private pilot in structure, but the material's just way more complex and different.
Okay.
Mm-hmm. So it's definitely less hours. I mean, but the minimum for private, I think you said was like 40, 45. It took me about 60 or 70 to get my private. Because I was going to school, I was doing other things, but the instrument was definitely less, but it is a much harder rating because it's just that it's a lot, it's different flying. So.
Cool. Thanks.
Yeah.
Can you go from one to the next?
Yeah, I did right away. Like the next weekend.
Okay. That's really good to know.
Oh yeah. And you guys will know what I'm talking. When you take your instrument, you get the rating. It's like, not to discredit VFR flying, but it truly is fair weather flying. And when you get into the system, I mean, you guys are going to be flying from some airport here in Houston. You're going to want to go across the Bravo airspace. You're going to want to transition the class Bravo. And when you're an instrument pilot, when you're a VFR pilot, air traffic control doesn't know that, right? They treat every pilot the same. So they're going to give you the same treatment. They're going to give you headings, vectors, altitudes, tell you to do crazy things. And if you're an instrument pilot, you're just that more prepared for those, requests and for that kind of flying. And oh, by the way, one of the biggest risks to VFR flying is weather. So if you're an instrument rated pilot, all of a sudden your ability to fly in different weather conditions becomes that much greater. And so your safety factor gets bigger and you become a safer pilot. So it's an insurance policy. It makes you more precise aviator. And I mean, it's more training, it's more money, but to me, it's like, man, it opens everything wide up. It lets you fly in more conditions and in more airspaces and stuff like that.
And that makes complete sense to me. I've also heard kind of the opposite, though, that if you don't continue to practice and if you aren't continuously flying and you have your IVF, then it's more risky because you can forget that information. Do you believe that?
I do, yeah. No, so I guess that is one detractor, if you want to call it. Because like the three of us, we're kind of business people, right? We think about return on investment. I'm going to go spend some money getting a rating. What's it for, right? With the caveat with the instrument rating, which applies to the private rating to some extent, is there's skill sets that you have to maintain. There's also regulations that you have to meet. So if you're an instrument pilot, you have to execute minimum 6 instrument approaches every 6 months. So for me to maintain my instrument rating, I have to go to the airport, get in the airplane, file an instrument flight plan, go to an airport, fly to an airport, do 6 approaches, and call it a day. And I have to do that every 6 months, which doesn't sound like a lot, but it actually is quite difficult to maintain that currency if you're not flying like all the time. And to your point about being precise and comfortable, instrument flying is extremely precise. Air traffic control expects you hold your headings plus or minus 5 degrees, your altitudes plus or minus 100, and your airspeeds plus or minus 10 knots. And they're basically barking vectors and altitude changes and speed changes. And I mean, you've got to be like on your game like all the time if you're on an instrument flight plan. And so yeah, if you I became an extremely rusty instrument pilot when I wasn't flying instruments at least once every month. You become extremely rusty.
Got it.
Do you have to do the same thing for the visual as far as a minimum amount that you log in?
Me personally, yes, I was not a comfortable VFR pilot if I wasn't at least flying once a month.
Yeah.
I could, when I went, if I look at my logbook and I'm like, holy crap, it's been 60 days. Like, I can definitely feel that. You were like, wow, I wasn't very crisp with my landings today or my course tracking. I wasn't really on course the whole time. I had to ask air traffic control to repeat what they said 3 times.
Yeah.
So no, for me, it's every 30 days. If I'm not up every 30 days, like I feel it. And from an instrument rating perspective, that's almost a minimum. I mean, shoot, if I had to go today and fly in like a hard instrument condition where you can't see the ground for the entire flight, I wouldn't feel comfortable. Literally, I'd have to, if I knew that weather was coming up, I would go to the airport with Emily and do a simulated instrument flight with no visual reference. I would looking only at the instrument panel.
Okay.
So yeah, 30 days. 30 days is definitely a bogey mark. All good, all good questions, guys. Any other thoughts, questions? It's all good stuff.
I'm good.
Good for now. Yeah.
All right. Well, I'm going to put some quiz questions together. I'm also going to do a short video on the wind correction angle. The next session, we're going to continue to talk about flight planning. We're going to focus more on radio navigation, GPS navigation. Now that we know how to calculate course lines and do it the way they used to do it back in the early 20th century, we're going to learn how to use some of the cockpit instruments and stuff like that. So other than that, we'll talk to you guys on Thursday.
Cool. You also mentioned a video. Are you going to send that link out?
I'll send, yeah, once I finish it here in a minute, I'll shoot it out.
Bravo. Awesome.
All righty.
Thanks, guys.
Yep. See you guys. Bye-bye.
That one?